Hello, hello. Are we live yet? Hello, hello. Okay, I think we're live. Are we live yet? I think we are live. Okay. So let me just say live now here. And yeah, so we have 3 minutes until day 11 opens up. Day 10, I think ስትሪሙ ላይ የጨረስነው ፓርስ ማድረጉን ብቻ ነበር so we parsed this structure. If we go to day 10 part 1 main arrays, so yeah, we implemented parsing it with gnome, the a parsing combinators library in Rust. So soon ነበር I think ትናንትና የጨረስነው. We tried some stuff to figure out the button click counts that would be required, but they didn't work out. So after the after the stream, like I looked into the Reddit and stuff like that, and people were talking about doing this. So you would convert your target into U32, and you do that by like basically starting off with 0 and setting 1 on like that given index. So for the first pattern, for example, like 0, for this one you would get like 0 1 1 0, which will end up like as 1 1 0, and then basically you do those shift operations on the for, and then you generate the masks for each of the buttons, and then you just keep on, you do like a search to count which searches result in the target, which button masks result in the target. But yeah, so this was our part 1, but the all of the solutions I was looking into, that did part 2. Like I didn't understand any of them. Some people were talking about, I don't know if you guys see so, but something called Z3. It's like a theorem solver, or I don't know what it is. But people were saying that's how you solve Z3. So yeah, no, in part 2. So in part 2, what you are doing is like you'll be given a list of junctions, and then those junctions result from the button presses, and then you have to find like the same similar problem, the minimum number of button presses that would be required to get this junction sequence. So yeah, I guess this one was hard. So what we're gonna do is I'm just gonna skip it for now, and then maybe once like we finished the whole day, like once we finished the whole like puzzle tomorrow, maybe then I'll try to port somebody else's solution to Rust, or like some existing solution. Try to find some existing solution. So that's the plan, but I don't think I'm gonna do that because yeah, it doesn't really make sense if I don't understand it to just type at the back. So okay, uh, day 11 opened up. Let's read it. Hopefully it will be easier. Shit. Okay. Mm-mm. Hopefully it will be easier. Yeah, I think they changed their layout here. So let's think we're live. Everything is going well. Let me go back here. Okay. You hear some loud beeping coming from a hatch in the floor of the factory, so you decide to check it out. Inside, you find several large electrical conduits and a ladder. Climbing down the ladder, you discover the source of the beeping, a large toroidal reactor which powers the factory above. Some elves here are hurriedly running between the reactor and the nearby server rack, apparently trying to fix something. One of the elves notices you and rushes you over. It's a good thing you're here. We've just installed a new server rack, but we aren't having any luck getting the reactor to communicate with it. You glance around the room and see a tangle of cables and devices running from the server rack to the reactor. She rushes off, returning a moment later with a list of the devices and their outputs, your puzzle input. So we have a so colon Juju. And maybe this is like a reference. So each line gives, I guess this looks like a graph from the input. This is like one of those, what are they? An associated list representation of a graph? Or what is it called? This looks like a graph. Okay, which line gives the name of the device followed by a list of devices to which its outputs are attached. So BBB is attached to DDD. No, BBB, okay, that means that BBB has two outputs, one leading to device DDD and the other leading to device EE. The elves are pretty sure that the issue isn't due to any specific device, but rather that the issue is triggered by data following some specific path through the devices. Data only ever flows from a device through its outputs. It can't flow backwards. After dividing up the work, the elves would like you to focus on devices starting with the one next to you. An elf hastily attaches a label which says you. Okay. Um, After defining, the elves would like you to focus on devices starting with the one next to you. An elf hastily attaches a label which says you, and ending with the main output to the reactor, which is the device was labeled out. To help the elves figure out which path is causing the issue, they need you to find every path from you to out. In this case, these are all of the. I think what we're gonna do is just build a graph, and then there is this library called Pate Graph. So Pate Graph, it's a graph library, and I think they have an path all simple paths. I think this maybe this will work. So from to, and then the minimum intermediate nodes, maximum intermediate nodes. I think we can use this library to get the count of the all of the paths. So let's just get started. So inputs example. Yeah, let me just clear this out. And then let me get the input. So maybe so is there an out label here? Out. Okay. Okay, let me just do this. Save. No, yeah, save. Quit. And then let's do the same thing. Let's take a look at the inputs. Save it to the workspace. Move input to inputs. Let's look at our inputs. Let's load them in. Let me increase the font so that you all will be able to see. So let's see. Input equals include star, which is gonna be outside of this, and then it's gonna be inputs example.text, and let's try to print it out. Input. I don't know if we will need I don't think we're gonna need a gnome or anything to parse this out. It's very simple. So we just split on that, split on those, and we're done. So I don't think I'm not gonna use what is it, gnome to parse this. So it's gonna be input dot lines dot map each line, and then we're gonna do this let something equals line dot split split once, I think. So we want makes sense. Split ones on the colon. Of course, this has to be no. This has to be a character colon. Right, and then unwrap, or we can say flat map and set hints false and short circuit here. We can do this instead, so we can say from and then comma 2s, and then we'll also need to do let 2s equals 2s that's dot trim, I guess, because dot trim and dot split split white space. Yes sir, yep, this is what we want. And what does this return? So it's gonna be from followed by 2s, and then I guess we would need to call from dot trim too. So from dot trim, and then this will be an okay. Split ones returns a result, or what do they say? Okay. Okay, or okay, this function the operator can only be used on null options in return. This should return I don't remember. Can we type this here, like saying stuff like this? This is a string to Vic string. No, we can actually. In that case, I just forget it. If this actually fails, it should error out. Oh, and then okay, I know what's wrong. So what I wanted to do was now it should work. Okay, now it should work. So let's do debug. These are not lines, but let's say connections, and then this is how we pass them. Let's look at connections. It should look correct. Should be correct. Cargo run. Oh, I guess I didn't collect it, so let's collect into a Vec. Yep, cargo run. Oh, this also needs to be collected. Vec. Yep, okay. Yep, that seems correct. And then what's the first one? So AAA, UU, HHH. So okay, this seems correct. Now let's add page graph, cargo add page graph. And then we will build our graph. How many kinds of graph do we have? They said it can't go back after, so the else are rather it's not, so the path goes to data only overflows from a device through its output. It can't flow backwards. It cannot flow backwards. So in that case, which is we would use a directed or an undirected. I think we would use a directed graph. Yeah, I think it is. Ages might be directed or undirected. Yeah, it doesn't matter, I guess. type undirected, node count, edge count. But here they use the directed graphs. Does it need to be a directed graph here? I think it needs into neighbors directed. So directed versus undirected graph. Direct graph have one-way connections, arrows showing asymmetric relations like websites, blah blah blah. While undirected graphs have two-way connections lines. So what we want is a directed graph. So I think the digraph example here works for us. Yeah, so we add the nodes, we iterate over and add the nodes, and then we will, so, and then we will iterate over and add the connections, and then we will add, I guess we will need to, would we need to specify the weight, or I guess we can just set 1 for all of them. We can also create it from this from ages function, which should work for us. Let's try that out, like actually. So what we need to do is let ages equals, we just need to split it out into these things into separate components. So let's do connections. So this should be a vec of a string comma string, and then we will just map over connections into iterator map over into iter map over each one, map over each from, let's do from comma twos, right? And then we in here we will say twos dot map the twos dot into iterator dot map, and we'll return a 2 here, and then they will return from dot to owned comma dot 2, and we'll go back here and then flatten that list, and then collect that and then no, why did that complain cargo oh, okay, so this should be 2 still. So let's look at actually connections. What else does it look like? Oh, it's an str followed by a vec of str, and then in that case, can we just say this then? I thought it would complain saying vec cargo. Okay, that works. What if we just do from in here? What if we just don't call to owned one? Would that work? No, from is borrowed. It won't work in that case. I guess I don't care about this, to be honest. Let's do to owned here as well. So we have our ages now, and then we can call from ages on page graph. Let's look at this. So this should be AAUU and then AAHH. This is correct. So let's say let graph equals digraph. From ages I guess we don't need to. Okay, we can just give it the ages. What you telling me? Ages. Do that. I think we need to give it more types. Let's see. It's a graph from maybe here to give it the types here. I'm not sure. Say okay, something like this. It's a string to string. Okay. From string is not implemented for node index. From string is not implemented for node index. I guess I'll not do a user32 then. I don't care about that. I guess this should look something like this then. So it should be 3 comma separated values, and then we would need to say it's 1 here. I don't know what you're telling me. Then we can remove this fully. Or we would say user32 here. And then string here maybe. Let's look at the directed graph itself. The digraph. I think they have examples. Examples creates. It only needs once to know the. We can say stuff like that. Let's look into how from ages works for this digraph. Digraph from. Creates a new graph from an iterable of ages. Node weights n are set to default values. Age weights e may either be specified in the list or they are filled with default values. Nodes are inserted automatically to match the ages. So this is just that's exactly what we have. But you're telling me let's see what we have here. So but in our case it's maybe it's something like this. This what I want to do. Can the nodes not be strings? This is great if the nodes cannot be strings. Yeah, here it's adding so we have to do the node is string, and then u32. Don't get it. Create a new graph by mapping node and edges to new values. But it's an ungraph here. Directed graph of strings pet graph. This is what we tried, but it's not working. Okay, you can't do from edges. I guess we have to do this instead. Okay, that's freaking annoying, but okay. So what we need to do is from here we need to produce two iterators, or I guess let's have it like this, and we will, let's say, nodes equals no, let's create the graph. So let's say new, so that's the graph. And then do they have get node? They have an add node, they have a node count, they have a row node, they have a remove node, retain node, try add node. Okay, so we need to do something like this for let's say that unique nodes equals connections dot into no edges dot, let's say, clone and into iterator, map over each one, get the from, get the to, and then we will produce something like from. How do you create an iterator of static values? Can you even do that? I don't think you can. If we have to do that, then let's say into iter and then flatten that, and then just collect on a hash state. Right, so these are the unique graphs. So let's say map equals hash map from string to I guess whatever we're gonna be getting, let's say u32 hash map new, and then for node in unique nodes, and then its graph should be created by now. So need to do let something equals graph dot add node. Which is gonna be node. and then we get something called a node index. It's that, where is that from? Let's say node index, which one it is, but let me try and add it to the map. Insert node, I guess a node, let's say to on here, and then the value is going to be something, or let's say index, change it to mid-level. What is this though? What is it? What is this node index type? I'm just gonna say it's 32 and see if it complains. Cargo. Okay, what node index? Adjacency graph. Okay, makes sense. So now we've added the nodes and we have their indices. So let's say from 2 and in ages, right? Here we would say something like graph, I guess. Let's source, let's say from equals map. I guess can you do this? I think you can. I think you can't do that. I guess you can. I don't know if you can do this. And then 2 we have the from in the 2, and then we can add the graph dot add age, and then this will be from comma 2 comma 1. Okay, we don't have any weight, so let's do that instead. Cargo run. Like this. Okay. Okay, now we have the graph. Let's use so we're asked to find the in this example, these are all the, so we need all so I guess in total there are 5 different paths. So let's say all simple paths, and then how is it used? Let's say let's do this path, let's do that, and then it's collect that. Let's get it here, and I'll go import page graph. I'll go, oh, I guess I don't care about Argo. All I want is this. So all simple paths for the given, where is the random set being imported from? Okay, from standard hash random set given this graph, and then what we gonna need is map at, so u, right, and then map at out. So these are all the things that we want, none, and let's just debug them out, or let's count the paths down lane. Hopefully it will work. It said 5. How many did it say here? 5 different paths. Okay, yep, that checks out. Should we look at the paths so that we know if it's actually correct? It's listing them out as node indexes, but it makes sense. So data could go from U to BB, then 1, 2, 3, 4, 5. So the first one will have 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 5. I think this is correct. I'm just gonna, yeah, I think this is correct. Should work for us. We use the graph library, but it should work for us, I think. Let's run it. Oh, I meant to log the lanes. It said 749. 749. Yeah, pet graph to the rescue. Nice. This is cool. How to improve the problem solving? No, I don't think my problem solving skills are getting better. If anything, they're getting worse. But if there's a library for it, I guess always use the library. So PageGraph solved it for us. And the reason I remember this is, I think if I search for it in my channel, PageGraph, yeah, so day 25. Okay, so back in 2023, I was doing Advent of Code, and so if we go to events here, so in 2023, I think I made it through almost the whole year, but yeah, but there was a similar problem like this where you needed to find all of the paths, and that's when I discovered people talking about page graph and stuff. So I guess problem solving is just, if you're getting exposed to as many problems as possible, you'd be picking up some stuff. I guess, for example, on Monday we learned about that union find data structure. I had never heard of it before. So yeah, I guess that's the, you just gotta keep doing more problems, and I guess you eventually have a like enough training data to predict the next tokens. So that makes sense. Okay, let me add this commit fit implement day 11 part 1 whimsical contrast size. Okay, let me just push that. And then let me go back out. Part 2 main arrays. No, there's another thing I want to change first. Cargo.toml, and this should be part 2 instead. And then let me open it up back again. Cargo run. Okay, seems this is working correctly. Oh, our inputs get changed. Okay, and then let me read the part 2. Thanks in part to your analysis, the elves have figured out a little bit about the issue. They now know that the problematic data path passes through the DAC, the digital to analog converter, and FFT, a device which performs a fast Fourier transform. I was afraid they were gonna ask us to implement a fast Fourier transform when I saw that. Okay, it's just the name of the thing. Okay, they are still not sure which specific path is the problem, and so they now need you to find every path from SVR, I guess that's server rack, to out. However, the paths you find must all visit both DAC and FFT in any order. Okay, for example, the new list of devices contains, um, I guess, did the example change? Yeah, I think it did. Let's take it. Although it hasn't changed, you can still, but the example has changed. The okay, the input hasn't changed, but the example has changed. However, the paths, okay, this new list of however, only two paths from HPR to out visit postdoc and 50. Find all of the paths that lead from. So I think what we can do is we can still call all simple paths and filter out the positions that contain either one of them. I think maybe that's the solution. Nice. I think today is gonna be easy probably, right? What else would we need to do? Because this is returning a wake of node indexes. So each wake node index is a list of connected connected nodes, or yeah, and then we can just do a dot contains on it, or dot includes us. I think we just solved it. Okay, inputs, example, let's say example 2 dot text. Let me copy over the new example, paste that in. I think we're gonna be finishing early with this today, with today's problem. Okay, so let's save this, and it's going to oh no, I saved it on the wrong place, in the wrong place. Let's take move inputs example.2 to part2 dot inputs and go to part 2, go run. Here we would say save example 2 dot text, and here, so we would say let with, no, I guess valid pauses false, and we can say paths dot into iterator map over, no, I guess filter each path, and in the path it's valid if path dot contains map either right, either FFT map FFT map or path that contains map at, what is it, DAC. And then let's do a dot count on this, and then let's say valid path. It's no entry found for key on line 52. Oh, okay, so we have to you're still gonna, okay, from server to out, from SVR to out. They are still not sure which way, so now they want to find every part from server. Previously were to out, however the path 6, are there 6? Only 2. Okay, maybe this will, I don't see how this affects the, oh Bose. Okay, this new list contains many paths, however only 2 paths from server visit both DAC and then I guess we gotta, oh, I guess that's a mistake on my part, we have to say end here. Yeah, not now it's 2. And then let's run it for our input. I think today's is gonna be easy. We just use the paid graph and paid graph did it for us. Ooh, that iterator is taking a while. This iterator. Yikes. Okay. Maybe they screwed us. Don't jinx it by saying it's easy. Yeah, I don't know. Maybe they jinxed that. It's taking a while to compute part 2. Shit. It's one of those things where we need to optimize stuff. I'm gonna throw another library at it. So there is this library called docs.rayon. So you can give it any iterator and no, you can give it an iterator and it will parallelize it and then compute each iteration in separate threads. So like if like it will just divide anything by the number of cores you have. Like so if some function was taking like 5 seconds or 4 seconds, when you throw rayon at it, it will just divide that by 4 if you have like 4 cores. But I don't think I have more than 4 cores, so I think maybe let's use this library rayon. This is bad, but let me just see this first. Let me just getting the path that lane is easy. No, I mean, so it's like we're getting this cargo R. No, so that's not where that's not where we're spending a whole bunch of time. Oh no, I guess from server to out is large, so we can't get all the simple paths. Okay, maybe there's a path. There is another way of getting the path. Simple path will look for any, but I think there is one where we can give it a conditional. I think there is one. I'm not sure here, but let's say pause. K shortest path, simple pauses, or simple path has path connecting. Has path connecting? Or simple paths. I guess simple paths, shortest path. We're not. Maybe simple path, all simple paths, multi, all simple path. I think there was a, and then let's do cargo release. There was a function in pagegraph paths covering nodes. I think there was a function for it. Pagegraph paths covering nodes. Hamiltonian path, traveling salesman problem. The minimum spanning tree depending on whether finding paths between A star. They have A star, I think. Oh no. Oof. What is this? Did my OBS just crash? Just crash? Or what is happening? Yeah, I'm gonna stop this. This is taking way too much time and it's taking up a lot of memory, I think my server crashed there for no, my machine was gonna crash there for a minute. It's when I run this. Yeah, it's taking up too much stuff, I think. Yeah, I'm not gonna run that. Let's search for A star. Is that what we want? They have A star. Shortest path. I don't know. The shortest path is not what we want. Dijkstra algorithm finds the shortest path. All simple path function can list all paths between two nodes that do not repeat nodes. Be aware the number of simple paths can grow exponentially, so this is only practical for a small graph or with relative limits. Mean spanning tree to form an approximate solution of the traveling salesman problem. I think maybe we can all simple paths. Okay, you can say, I guess there's nothing. This algorithm is adapted from NetworkX uh, graph. We can maybe. No, it's not gonna work. That's not gonna work. Or simple pause multi. What about this one? What does this from to? Oh, I guess from a single source to multiple targets. Or simple path accept a hash set of target nodes. Okay. Mean intermediate nodes, max intermediate nodes. Path. Okay. Sort by key. Yeah, they screwed us with that one. So let me see. Inputs. SVR and you. Yeah. How like 606? This doesn't seem like a lot of nodes. How many nodes do we have? Let me see. Main.rs. Let's say debug unique nodes links. $607 unique nodes. Okay, settings, force. And I don't know what all simple paths does if there are cycles. Maybe that's where it's getting stuck. So cycles. It doesn't matter if there are cycles unless until I guess what if it gets caught in a cycle before it reaches. So I think maybe we need to be smart. So we can say we can get all of the ones that start from SVR and end at all of the paths that start from server and end at the fast Fourier transform, and then we can say find all of them that go from fast Fourier transform to DAC, and then we can say uh, uh, find all of them that go from DAC to out, and then we can combine all of those three path searches into one giant list and then filter out those that contain all three instead of going to just finding all of them that go from server to out. Maybe that will reduce the number of. So let's go, and here we would say SVR to FFT. So here we would say SVR to FFT, and then in the next line we will say FFT to DAC, FFT to DAC, and then we will say DAC to out. I think maybe this will help us filter the number of nodes we need to touch, and then the loop will be we would basically just let valid pause will be SVR FFT dot concas. I guess no, not that concat, but is it join? No, not join. How do you chain? Okay, I think it's chain, yeah. Iterator dot chain. Yeah, let's just do intuiter on that, and then oh no, I don't think we can just chain them, right? We have to join them up in some way. we have to join the map in some way. So we have to start from this, join these two, and then join these two. Okay, joint is gonna be svr.a50 dot intuiterator dot map, and for each path we are going to get the last one. So path dot last, we always have something at the end, so we can just unwrap that. So this last index is so let's say a50. So first we're gonna find the path where the last of the current SVR is the end of the first of the A50. So A50 dot find let's say dot ether dot find, no, not that full, but dot find, and the predicate is gonna be where the path, let's say, let's call this P, and then let's say P dot first dot unwrap is going to be, we can just say I guess dot 0, I guess here, but I guess that makes more sense. That's more American, equals to last. So this is gonna be something like a flat map. So if we find one, if we find that first, or I guess let's say is some here. So if we connects, let's call this connects. If it connects, right, we will need to do something like, no, I guess we'll need this. We'll need that value. So let's say this is not. We'll need that path to join it with the current one. So let's say that clone. Okay, this is correct. And then we will need to, okay, I guess let's do match connects and fill the arms path. That gives a50 path. We're gonna say the current path dot concat. Maybe we need to remove the last one from this. We need to, I guess we need to do something like this. We need to say path dot pub, and then path dot concat with a50 path. The method concat exists for vacant index, but following the trade bounds cargo R, we just want to join them together. So how do I extend from slice? Okay, in that case we don't need to clone it, I think, here. Yeah, we don't. And I guess if we didn't find find a start in the A50 for this one, this should just return a none. Right, in this case this should be something like this then. Then this should be pop-up, 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 pop-up. Okay, these are the ones that are joined with the A50, and then we need to do a very similar thing for the other part as well. So we need to get the mutable paths and copy all of this, paste it in here, and then but here we will look for it in doc out. We're gonna say the last of the current one. That do you find that in the doc out? If you do, this is a let's say it's I don't know if this is gonna help, but let's see. I think this will work. So we just joined all of them together, and then we will count this. I guess this is valid paths now, and then we'll just try debugging it again. Hopefully this works. Unique nodes not got printed, but let's see which one takes the longest. Maybe let's see if this one completes first. Lane, and then debug A50 lane, and then dot out.lane. Also, let's switch to the example so that we we know that we're still correct. Valid path ends up being 1, but it should be 2. How would we miss those? Maybe this, we don't need to pop here. Doc pause, find doc out, the first one. Maybe we don't need to pop here. I think so. So the last of the is okay. If any of them that ended here, do we find the same index at the start for the other ones? If we do find one, we remove the first one and we extend it with the rest of the other slice, and we return that value, and then we do the same for the why doesn't this work? At this point we got 2 values, but okay, so what we need to do is not find, but I think we need to find like filter instead. Filter, so we could have multiple A50 paths, right? So in that case we will need to still pop, but we will need to create multiple paths, right? So I think pause, there could be multiple that start with the current one, not just a single one, so we want to keep track of all of them. So we would need to pause dot, I guess no, A50 pause, this should be A50 pause. Yes, if A50 pause dot lane dot count, or I guess we need to call like this. If dot lane is equals to 0, then return none. And then otherwise we'll do our stuff here. So let's we need to go over like this A50 pause dot into iterator dot map each FFT pass word. Just clone it and extend it from the slide. That's the slides, and this will return a collect that will be this. I guess we don't need to collect this. We can just ba-ba-boom, 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 boom, boom, ba-ba-boom, boom, 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 boom. Something like this. And then we'll need to see what this is. We'll need to, this should just be a map. And we'll need to call dot flan here. Or I guess it should be a flat, no, it should be a flat map, but here we will need to do something like this. Path.concat. Isn't that how do you like join two vegs together? Rest join two vegs. I guess chain in collect, append extend. In that case, we will need to keep a clone of it in here. Let p equals path dot clone and p dot append fft path, and then this will return API. Okay, this is what we want, and then we return the P, and then we don't need to call flatten on this, I think. Wouldn't that just handle it? Okay. Move. Okay. Mute. Cannot borrow as mutable. Cannot borrow data in. Okay. Why can't I do that? This is supposed to be an into iterator. And I guess this should be into iter as well. But here let's clone it first. And then we need to just perform the same logic for this one. So last FFT path will be DAC path. This makes sense for me, I think. Okay, now valid path is 2. So let's, I think since we know now it's correct, let's run this on the input, but I don't see it working. I don't see it working, to be honest. So even finding the first server to FFT paths is taking a whole bunch of time. Bunch of time. Page graph, all paths passing through nodes. Find paths through nodes. It takes that graph, start node, intermediate nodes, and just checks if it contains, but that's not what we wanted. That's what we implemented earlier, but that didn't end up being correct. I think I jinxed it. We've been here for 1 hour. I jinxed it. Shit. Okay, let's see. Do we have to implement it ourselves? I don't think. Maybe it's not like, is there a built-in function we can use? Maybe, I think we don't have to collect it. We can maybe just iterate over it. Yeah, maybe just the collecting them was taking a lot of time. What if we don't collect it and work with the iterator? So I guess you can't clone an iterator, or I guess you can clone it, but this is how you do that. Cloned. Here too is clone, okay. And then the expected found. Okay, this is an iterator that will return. I guess it's already an iterator. We can clone it and done like the clone, for example. I guess we can clone the element, so we can filter for the first one, but cloned should be, I think we need that. In that case, maybe we need to call the functions inside of this every single time, though. That's gonna take a whole bunch of time. Not sure about this. Yeah, it's not gonna work. Yeah, it will be moved. So we would have to call the all simple paths function here. I don't think that's gonna work. I don't think that's gonna work. we can use the uh, 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 maybe we can make the connection between all other nodes very large, and then decrease the connection between this like the nodes between like the what we're filtering for, uh, and then we can get the shortest paths. I guess we'll only be able to get one single shortest path, not a set of shortest paths. It's not, that doesn't make any sense. Let's look at the parameters of all simple paths again. It's graph from to and then max intermediate nodes. We can, I guess we know that the okay, let's undo all of this stuff. I don't think it's gonna work. I think this is even making us cover more nodes that shouldn't be covered. Undo all of this stuff. Let's go back to the first solution we wrote, and this is what we had. So from server to out, and all of them contain, yep, this is what we had, I think. Example 2, and then let me run this. Okay, so here we can say the intermediate, so at least we know that there will be a minimum of like two intermediate nodes, and those should be F50 and DAC. And what's the other parameter? It's the maximum number of intermediate nodes. I don't think we know that, because the graph could be very large. We don't know that. And also, I think another thing I want to try out is I'm gonna export it into, so let's run this. Let's see if that makes a difference. And then I'm gonna see how we can export it, how we can export the graph into a dot format. Exporting graphs, so you can say basic dot, and basically just write it to a file. Okay, gonna ignore this for now. Let's comment this out, and paste that in. It's not gonna find it. I'm gonna stop this, and let's import page graph. You're gonna be given the graph and basic dot. I guess you just call dot to string on it. And then I'm gonna write this to a file, standard fs write, let's call this graph dot graph. I don't know, what's the dot graph extension? I guess we can call it dot, and it will be this dot graph and negative it failed unwrap. Yep, that's what I want and write it. Okay, let's look at that graph dot dot. So this is our graph. That's graph is online, and let's see what our graph looks like. Ooh, what the heck? This is the graph. It's giant. Holy shit. Like, let's compare this from like to our example. This looks like a Node.js dependency graph, not a what are they doing? What the heck? Come on. Let's say and then okay, let's call this example dot dot, and let's actually compare it with the example cargo run and example dot dot. This is nothing compared to that. This is the example they showed us. So all of them start from the server, they go to FFT here, and then I guess there is also like oh, this is FFF, okay, and then they go to out. So this is like simple, but the other ones I was like, what the heck? Maybe we can manually find it. I don't know, manually count them. I don't know. I'm not gonna do that, but so let's look. Let's see. So they all start with. Let's do this. They all start with server SVR, and we should see A50, which is the next one, right? So A50 somewhere around here. Yeah, let me just remove this, and we should be able to see A50 somewhere around this. I'm not seeing it though. Can I search here? A50. Where is A50? Then all of them going to these three nodes, and then they branch off from there, and then they go into these three nodes, and then this four. Holy shit, this is way too many connections. And then look at how many of them end on out. This is crazy stuff. Ah, snap. I'm not finding A50. I guess there are just too many nodes to look at. Wow, that's just a giant graph. Yeah. How long have we been here? They used to show me the time here, I guess. Okay, 1 hour and 20 minutes. I'm gonna ask ChatGPT for like all pay. Is there a function in pet graph to get all the paths, the path that end, that start at a given node and end at a given node while passing through a set of intermediate nodes. Yeah, this is what I was trying to do earlier. Compute all simple paths between each adjacent pair, like start to like we did, but that didn't work. So we were trying to find the like all of them from server to A50 and then A50 to dock and then dock to out and then just join them together, join all of them together, but that didn't end up working. Wait a minute, wait a minute, that could work, that could actually work, but we don't start from the first one, we start from the last one. I think that will decrease the number of paths we would need to touch. If we start from the last one and uh, go forward, I think it would, right? And then this is how we would create our own like DFS constraints. But is this using will this work? I don't see our function being more optimized than the all simple path function from PageGraph, but let me see. And then this should be a digraph, but from string to add. And then I guess we can go down here and say copy this. DFS constraint. It will first take the graph and the current, the end, the required. I guess it will be a wake of map A50 and map DAC. And then the visited queue is just gonna be an empty wake. Oh, result is also gonna be there. Okay. Mm-mm. Mute. What does it return? It doesn't return anything. I guess it's like a C kind of thing. Okay, let's say let result equals wake the new, and we will pass it as a thing like this. And let's change it to be mutable. And then let's debug result length. Yes, that'll take some time. if this node is required, remove it from the list. Is not required or is required? Required or is empty? This is what we want, all paths passing through in a specific order, because I think they might screw us by doing like DAC and then F50, but that doesn't matter according to our input, right? Must also visit both DAC and F50, but they don't say like they have to be in order. I think they screw this. I'm gonna try one last approach, and I will end the stream. I think, let me see, how long have we been here? So 1 hour and 25 minutes, or 1 hour and 32 minutes. Okay, so I'm gonna try one last approach, and I'm gonna end the stream. So it's gonna be something like this. So let me delete this. I think it's not, that wasn't gonna work, because the old simple path function is already memoized and heavily optimized, so I think that's where we should be spending our time. We should do something like this. So let's comment this out. Let's try to find all the simple paths from out to knowledge, from the AC to out, and then they will have 0 intermediate paths, and then requirements, and let's import that. And here let's just debug paths lane. And then let's see, let's run it on the input. How long does that take? Okay, beautiful, that returned almost instantly. And then let's see how long this will take. Let's say from F50 to DAC. I think the first one is what takes a whole bunch of time. F50 to DAC. Oh no. Okay, let me. So the second one also takes a bunch of time. Hardcore run. Yeah, so at this point what we should be doing is, I'm gonna reduce the graph to remove all of the other ones that are not connected to the current, like that are not part of the current sequence of. So this thing returns 13,875 nodes. So if a node is not within these 13,875 nodes, we should remove it from the graph, and all of its edges with it. I think that is correct. So we just got all of those that start with DAC and end with out. But we would be deleting all of the ones that are before. Which ones are we going to delete? I think this gives us some information to work with. So we have can we go backwards, like from the last node to the middle node, and filter out the graph as like while calling all simple paths for each segment. What does this tell us? If it's not part of the, and it's not a, I don't think it tells us a lot of stuff, to be honest. Hmm. I guess we can prune all of the ones that are in the middle of this, because we already know that right, I'm not sure though. Segmenting around intermediate nodes. Um, the thing is, we can't start from the first one, because if we look at how much time it takes us to compute the first one, so let's say from SVR to F50, that's a very long time, so it's not gonna end quickly. It takes a whole bunch of time. If we remove those, what will we get? I guess basically we're filtering for if all of those DACs connect to an F50 backwards. Um, yeah, this is gonna take a whole bunch of time. It's gonna finish. Yeah, I'm also using an external library, but like a Zeta Python library that already has all simple paths with filtered. I'm using a library called PateGraph, and it has this all simple paths function. But the thing is, it doesn't allow me to filter the like the points in the middle. So I'm currently like trying to, and then we render the map. We rendered the graph. So this is this is the graph for my input, and it's taking, yeah. So yeah, and then the old simple path function doesn't allow us to pass in like the paths you return should all visit this set of nodes. It doesn't allow us to do that. But yeah, I guess compared to yesterday's problem, today is pretty really easy. What library did you use? What library did you use? Maybe I can look into that. Is it a Python library? Or I think you said you were using C++. Uh, yeah, we solved it, like we solved part one like in like 30 minutes, but part two was is annoying. I think still going in the reverse direction is still a good idea, but I don't know if this gives us enough information on what we should delete. Let me remove this graph stuff. So the final one is gonna be from the AC to out, and then cargo around that. And then we can just map over each one of them and take the first one, because we don't really care about the rest of them, because we're not asked to list all of the counts. But what do we do after we have all the first ones? We need to call all simple paths again, but for each one of them, for each one of those, this is like, I don't know, 13,808, okay, 13,875 nodes that just go from DAC to out. Wow. Let's go into even then some of the solution had running time of, oh wow, 10 to 15 minutes. Can you count the number of paths without generating the paths? Oh yeah, we can't count them. I think you're right, maybe let's try doing that. But we will need to, I guess. Okay, so there are like, how would we know about the connections? We can do dot count here, and that will give us the count instead of like generating all the paths, but I think it's basically the same thing. And then if we say from SVR to out, I guess it's correct. I don't think this is gonna improve it. 10 to 15 minutes, we haven't even let our solution run, any of our solutions run for 10 to 15 minutes. Wow. I guess if we're gonna have to do that, and then I don't think this will make a difference, because I think all simple paths will enumerate all of the paths regardless. I don't think we can just count them. Which algo you used in? Yep, we use this all simple path function from PageGraph. This function. This is how we solve the part one. Even today's part two needed memoization, otherwise we'll take a lot. Okay, memoization. Okay, even the running. Can you count the number of paths without generating? I don't think we can do that with this function. Maybe we should look into other graph libraries in Rust. Graph libraries, platters. No, that's not that. That's not the kind of graph I'm going. Graph data structure. There is something called Griff. I've never heard of this. Maybe this one. Okay, shortest graph. I guess it's only calculating the shortest one. Yeah, we starting from day, I guess, what guitar frictons are made of code. Starting from day 9 or so, we just decided to use Rust for the rest of them, because the other problems were getting difficult, and not by using a language like you are unfamiliar with doesn't really help. So we just decided to use Rust for all the rest of them. There's only one left, one challenge left after today. So we're gonna use Rust for that as well. But yeah, yeah, still going. I don't think I'm gonna wait for it for this long. We waited for 3 minutes. Um, so it's revert server to out and collect. I think it's still creating the vector, even if we tell it not to, or like we don't ask it to return that. But so it's just, I'm gonna revert back to my naive implementation of the first my naive first implementation. I'm gonna do this. I'm gonna take example. I guess, yeah, for this one doesn't really make sense to have the previous example inputs example. Take a step, move inputs example to inputs example, insert example. That's correct. Let's remove the unique stuff. Commit fit. I'm gonna say implement day one part. Not day 11, right? We're on day 11, right? Yeah. Oh wait, what did I say for the previous commit? Yeah, we commit part 2 working with example. Yeah, okay, take the part 15. I think if we have time, I still want to try out one thing. So let's just go. Let's try to go to the reverse direction. Let's go from out to DAC. How many will that give us? Will that actually return any points? I think since it's a directed graph, this will just be 0, I think. Yeah, 0. Okay, let's just do then I guess what I'm gonna try to do is for paths and paths. No, for path in paths, we will have the wake of node indexes that are contained within that path, and I'm gonna just try remove node, remove from the graph if it exists and returns its weight. If it doesn't exist, okay, I'm just gonna, I guess, and then for node in path, I don't know if that will help us, but graph dot remove node. Why? Oh, I guess I don't care about that. And then maybe we can try calling that's not gonna help. It's just server to out. uh, yeah, we've removed all of them. In that case, continue, so that we don't remove. Will the connections still be intact? That's what I don't know about. Yeah, we've removed all of the intermediate connections, so now it's just gonna be, I guess we can add an edge. In that case, graph, I guess for each path we will just add an edge, multiple edges. um just gonna be from, I guess we already know that there's gonna be, it's not gonna help us. We need to know what was before the first one, right? All of the nodes that are connected to that, that's not gonna work. There may be a replace node, or node count, edge count. Look up if there is an edge from A to B. Computes an O to E. Find edge. I don't know. I think I'm just gonna revert back and I'm gonna call it quits. Yeah, we yeah, this is it, right? Yeah, this is what we had. So yeah, hopefully, okay. Comments. Are you doing Yep. For part two, it's, you have to traverse all paths just like part one, and then you need to mark if the AC and FT or not, and then the final return video target if the post up and are visited, and then add the right there. Yeah, I guess. Think we've been here for almost 2 hours. Yeah, I'm gonna just call it quits now, or maybe just I'm gonna keep this running in the background. If it returns a result, hopefully it will return a result, but if it doesn't, yeah, it didn't. Yeah, see you tomorrow. Hopefully tomorrow will be like relatively easy, just like just like today's one. So, but goodbye.